In this video, we're going to talk about solving radical equations, and we'll do a series of 5 examples together, and then you'll have a chance to practice them on your own. Let's start off with example 1. We're going to try to solve the cube root of x minus 4 equals negative 3. Their first job is to always isolate the radical. Okay, so in this case, I would have to add 4 in order to accomplish that task. If we do, we end up with the cube root of x equals 1. And now to undo the cube root of a number, I can raise to the third power. So I'm going to raise both sides of the equation to the third power. And when I cube a cube root, I end up with just x, and 1 to the third is 1. So x equals 1 appears to be our solution, but I'm going to get us in the habit of checking, especially in this particular section, because what may appear to be a solution actually might not be. In this case, if we check x equals 1, that would mean the cube root of 1 minus 4 should be equal to negative 3. Well, the cube root of 1 is 1, and 1 minus 4 is negative 3. We'd get negative 3 equals negative 3, and we would be in business. So I know our answer is definitely x equals 1. Let's take a look at example 2. Here, I want to also isolate the radical term. It's being multiplied right now by a negative 1. So I'm going to divide both sides by a negative 1, and if I do, I get x to the 2 over 3 power equals positive 49. Now, I want to raise both sides to a power that will undo raising to the 2/3, and that would be the reciprocal power 3/2, because if you multiply 2/3 and 3/2, those common factors all cancel out, and you'd end up with x all by itself. So if I raise to the 3/2 on the left, I'm going to have to raise to 3/2 on the right. What a lot of students forget here, though, is they are taking an even root, in this case a square root, of both sides, and you sometimes lose sight of that when you raise both sides to a rational exponent. So when I have an even root, I have to remember it's really plus or minus 49 to the 3/2 power. Now we can actually do a little bit more simplifying here. If you recall in the first section, if you have a rational exponent, we can sometimes simplify by first applying the root and then raising to that power 3. So in this case, I have the second root, or the square root of 49, so I know I get plus or minus 7 to the third, which is plus or minus 343. So it appears that this is our answer. Let's check. If we were to check, I'd have to have the opposite of, let's do positive 343, raised to the 2/3, and that should be equal to negative 49. Let's see, negative 40. Hello, I'm having a hard time here on that part of the screen. Oops, let me erase that here. So that should be equal to negative 49. Now, if you put this into your calculator, I'm going to tell you, you get 49. Same as cube rooting 343, which would be 7, and then squaring 7 to get 49. But don't forget, there's the negative in front, so you get negative 49 equals negative 49. We're all happy. If you tried to check negative 343, okay, to the 2/3 equals negative 49. Oops, let's undo that last stroke. Equals negative 49. We would also get negative 49. If you type this into your calculator in parentheses, you can cube root negative 343 and get negative 7, and when you square it, you get 49, but the negative in front still keeps it negative 49, and you'd get negative 49 equals negative 49. So our solution here is in fact correct. Example 3. Once again, your first objective, guys, whenever you're solving these radical equations, is we want to end up isolating the radical. If I go to the right problem, I'm sorry about that. Let's go back to example 3. What we want to do here is isolate the radical. So if we want to get this radical by itself, I'm going to add 1 first. And I end up with the square root of 3x plus 4 equal to 8. Now I'm ready to undo that square root, and to undo a square root, we would square both sides of an equation. So if I square both sides, I end up with just 3x plus 4 on the inside, and then 64 on this side. Remember, when you're squaring, no need for plus or minus, right? We're undoing, we're not square rooting anything. Now I would just subtract 4 and we would get 3x equals a 60. This is turning out nice. If we divide by 3, we get a nice integer answer of 20, or at least it appears that way. Let's check here. So if we were to check, if we try x equals 20 into the original, we would have the square root of 3 times a 20 plus a 4 in the radical, and then when we subtract 1, we should get 7. Well, 3 times 20 is 60, and if we add 4, we'll have really a 64 inside the radical, and the square root of 64 is 8. If you subtract 1, you get 7 equals 7, and we are in business once again. Let's go on to a little bit more challenging of a problem. Example 4. Here, I have 2 radicals. This is where you have to make a choice. Your first job is still to pick, and let's write this down. What you're going to need to do is choose one radical to isolate. Now, sometimes by doing that, you'll end up isolating both, but let's just say, let's get this guy by itself first. So if I'm going to get this radical by itself, I have to add the square root of x plus 3, that entire term, square root of x plus 3, to both sides of the equation. That would leave me with, on the left, the square root of 2x minus 5 equal to the square root of x plus 3. Now, I'm going to concentrate just on this left side. If I want to undo the square root of that 2x minus 5, I would need to square this side, and if I square that side, I'm going to have to square this side. If I square a square root, I just get the radicand, 2x minus 5. On this side, if I square the square root, I get just x plus 3. Well, now we're on easy street. We're in like Algebra 1 land, and if I subtract x from both sides, I'd get x minus 5 equals 3. And if you add 5 to both sides, you'll get x is 8, apparently. I'm going to check, though, and make sure that this is, in fact, going to work. If I check x equals 8, in the original, I'll get the square root of 2 times 8 minus 5 minus the square root of 8 plus 3 should equal 0. Well, 2 times 8 minus 5 is 16 minus 5. I get root 11 minus root 11 equals 0. And hey, that is true. 0 equals 0. So x equals 8 is the solution. The last example I'm going to do with you is the most interesting. And in this case, we kind of luck out because the first step is done for us. The radical is already by itself just waiting to be undone. So I have the square root of x, and what I'm going to do to undo the square root is square both sides. If I square the right side, I'm going to square the left side. Now when I do the right side, of course, I just get x. Please do not write this for that side. This is a classic mistake. Do not just simply distribute that power. This is not a power of a product or anything like that. What we have to do is rewrite x minus 2 and square that binomial. So if you were to multiply all that out, right, and do first, inner, outer, last, I think you'd end up with x squared minus 4x plus 4, and that would be equal to x. Now what I'm going to do is set it equal to 0. We have a quadratic, right, equation. It's got an x squared in it. So what we have to do is set it equal to 0. I'm going to subtract the x from both sides. So now I have x squared minus 5x plus 4 equal to 0. And right now I'm hoping for a quadratic that's factorable because that's the easiest thing to do. I don't want to have to use the quadratic formula or complete the square. And I think I can come up with two numbers that multiply to make 4 and that add to make negative 5. And that would be negative 4 times a negative 1. Negative 4 times negative 1 is 4. And if you add them, you'll get negative 5. If you recall, all you have to do to solve now is set each factor equal to 0. So I'd get x equals 4. And if I set x minus 1 equal to 0, I'd get x equals 1. Apparently, these look like great solutions. Let's check them both. Always important to check both. If I check x equals 4 into the original, I'd get 4 minus 2 equals the square root of 4. Well, this is 2 equals 2. And, all right, x equals 4, looking good. If I try x equals 1, then I'd get 1 minus 2 equals the square root of 1. And 1 minus 2 is negative 1, but the square root of 1 is just positive 1. This is not true. That means this solution is actually not a solution. What we call this, guys, this is an extraneous solution. And what that means is it's like an extra solution that we got and we solved correctly. There was nothing that we did mathematically incorrect about getting this guy, but it is not true. We can't do it. And sometimes that will happen when you square both sides of an equation. You might accidentally get some extraneous solutions going on, squaring or raising to a fourth power, raising both sides of an equation to an even power. We could potentially run into this issue. So our only answer is x equals 4. The last thing I'm going to have you guys do now is you have a few problems to try on your own. We'll talk about them next day in class. Good luck, and again, don't hesitate to look back at some old problems that we just did to maybe give you a little hint in the right direction. Okay? Good luck.